Chemistry, we're moving on to our next lesson in periodic trends, and this one deals with the subject of electronegativity. So an electron is held with a binding energy that is a negative number. It's just defined as a negative number. Ionization energy, which we studied in the last lesson, is a positive number that cancels the binding energy. And so the positive cancels out the negative, and that allows the electron to be released from the atom. So there you see the binding energy of this electron is 520.2 kilojoules per mole. We saw that number in the last lesson. Now here comes an ionization energy of positive 520.2 kilojoules per mole put into the atom to remove the electron. And there goes the electron. So it's been ionized, and it's created an ion out of that lithium atom. Is now a lithium ion. It has more protons than electrons. That makes it a cation. So energy into an atom is positive, like money into your bank account. Energy out of an atom is negative, like money out of your bank account. So electron affinity is how much an atom wants to pull an electron toward it from the outside. In a sense, it's kind of the opposite of ionization energy. Ionization energy goes into the atom and pulls out an electron. Electron affinity, an electron goes into an atom and lets off energy. So there you see the electron going in, and there you see the energy coming out. So when fluorine accepts an electron, it releases 328 kilojoules per mole of energy. It's a negative 328 because the energy is going out. Like money out of your bank account, it's a negative. The release of energy takes fluorine to a lower energy state, which makes it happier. So the electron affinity for fluorine is negative 328 kilojoules per mole. Electronegativity is how much an atom wants to pull on an electron from an atom to which it is covalently bonded. And that's to be discussed later. We'll talk about covalent bonds in a couple of lessons from now. In this class and many chemistry books, the word electronegativity is used to include both electronegativity and electron affinity. So if you read your textbook, you'll see that it hardly ever uses the word electron affinity. It does use the word electronegativity, and it kind of means that at any time that an atom wants to pull in an electron, it's referred to as electronegativity. Electronegativity is measured on the Pauling scale. The values range from 0 to 4.0. So fluorine has the highest electronegativity, and that's at 4.0. There's no unit of measure to it. It's just a numeric scale, 0 to 4. So electronegativity is how much an atom wants to pull an electron toward it, either from an outside atom or from an atom to which it is covalently bonded. So we're going to use electronegativity for both of those situations. So the man represents electronegativity. Electronegativity wants to pull in an electron. There goes the electron into the atom. So electronegativity is measured on a scale of 0 to 4 called the Pauling scale. Fluorine has the highest electronegativity at 4.0. In this course, we will use the term electronegativity to mean both electronegativity and electron affinity. Electronegativity increases as you go up a group and right in a period. So there you see an arrow to the right and an arrow going up. This is exactly the same pattern as ionization energy. So the elements in the upper right-hand corner of the periodic table have the highest electronegativities. The ones on the lower left have the lowest electronegativities. So I kind of refer to the ones in the upper right because they have the highest electronegativities and the highest ionization energies. That means they really want to pull in electrons, and high ionization energy means they don't give up their electrons easily. It takes a lot of energy to take an electron away from them. So I call them the strong guys. And over on the left side, they have low ionization energies. They easily give up electrons, and they have low electronegativity, so they don't very easily pull in electrons from the outside. So I refer to the left side of the periodic table as the weak guys. You got the strong guys on the right, the weak guys on the left. So electronegativity is greatest in the upper right-hand corner of the periodic table where fluorine is, and that's the highest over there on the right and lowest over there on the left. That's the same perspective. So again, the same pattern across the periodic table as ionization energy. The elements on the right side of the periodic table are called the noble gases. That would be helium, neon, argon, krypton on down. Noble gases have no electronegativity, and we'll learn the reason for this later. Well, actually, we're going to learn the reason for it now. So the lowest electronegativities are in the bottom left. The highest electronegativities are on the upper right. So you'll notice this periodic table shown here doesn't have helium, neon, argon, krypton. It doesn't have the noble gases, the far right column. Why? Because noble gases are not shown because they have no electronegativity. That's because they have a full outer orbital. In order for them to take in an electron, they'd have to create a new orbital. So neon, for example, has two orbitals and they're both filled. If it wanted to take in another electron, it would have to put it in the third orbital. It really doesn't want to do that. It doesn't want to build a third orbital to take in another electron. So it's simply the second orbital is filled and the outer orbital of the noble gases are all filled from top to bottom, and therefore they don't want to take in any more electrons. So they have no electronegativities. They have no desire to pull in outside electrons. Okay, so now we're going to look at how electronegativity changes as you go across the periodic table, across a row and up or down a group. And you're going to find it's the same as for ionization energies. So electronegativities are highest when an atom has fewer orbitals and the nucleus has more protons. So again, fluorine, just as in our example for ionization energies, has the highest electronegativity. So why is that? So lithium has a lower electronegativity than fluorine because it has the same number of orbitals but fewer protons. So lithium doesn't pull in electrons outside of it as well as fluorine. Bromine has a lower electronegativity than fluorine because bromine has more orbitals and more core electrons and valence electrons. The electrons outside of the atom are screened more from the nucleus of bromine, so the atom can't pull in electrons as well. So it's much the same reasoning as it is for ionization energy. As you go from left to right, you get more and more protons with the same number of orbitals, so that means the atoms on the right, like fluorine, can reach outside of themselves and pull in an electron really well. When you go down to bromine, there's so many electrons there that it's hard for the nucleus to reach outside of itself to pull in another electron. It's much easier for fluorine to do that with only two orbitals, and therefore bromine does not have a high electronegativity. It does not do a good job of pulling in electrons. And that takes care of our lesson on electronegativity.